I'm not going to put that box back up. I think that 10.5, 10.6 was a failed experiment on that, but it was an experiment nonetheless, so you have one that has it in there. Just how it goes. So we're just going to talk through here our law of sines. So now we're going to be looking at law of sines and law of cosines. So when I talk about congruent triangles, so let's talk about that a little bit first. We can have side angle side is a congruence axiom. If you have side angle side, then I know I have a side, an angle between, and another side. If you have that criteria here, side, angle, and side, then you know everything else in the triangle is also congruent. Likewise, if you have angle, the in-between side, and another angle, then you can have an angle, the in-between side, and another angle that is congruent, then everything else is also. If you have side, side, side congruent, then everything else is also, right? So here are those different axioms saying if this criteria is met between two triangles, then you know everything else is also automatically congruent. All right, so here is our law of sines. Our law of sines says in any triangle ABC with sides ABC, the following hold. So anytime you have any triangle, so law of sines and cosines, I should have said this, deal with something outside of a right triangle. So up to this point, we've said everything is a right triangle. Well, that's not reality, y'all. You know that's not reality. You can still do trig with triangles that are not right triangles, which is awesome. And that's what we're going to do now. I have angle A. Across from angle A is side A. Across from angle B is side B, and across from angle C is side C. The angles are denoted by capital letters. The sides are denoted by lowercase, and I can identify them by the ones that are across. So when we go to set up these ratios, that's the whole purpose of law of sines, is to have the ratio. You can have the side that goes with the angle. And every single one of these ratios are equivalent. You can also put the angle on top and the side on the bottom, and every single one of these ratios are equivalent. All right? The whole purpose of law of sines here is to set up our ratios, and then we can solve that. Here's a good practice tip. It is good practice to put your unknown in the numerator. So if I'm solving for an angle measurement, then I'm going to put that in the numerator. If I'm solving for a side, then I'm going to put that in the numerator. All right? Okay. So here we have 4 cases. When I'm trying to find an oblique triangle here, I'm solving for these oblique triangles. Oblique just means not right? It's just a bigger triangle that I have. Then these first 2 cases are going to deal in terms of the law of sines. These bottom 2 cases, that's 11.2 for us, are going to deal in terms of law of cosines. All right. So my first case, I can either have one side 2 angles where I have side, angle, angle. So I have 2 angles in some capacity, either together or apart with a side in the middle, angle, side, angle. All right. So that is my setup here. Or I can have 2 sides and 1 angle. But the 2 sides have to be together. And then my 1 angle is outside of that. All right. Okay. This case is the fancy pants one. You can have 0, 1, or 2 triangles, and it's called the ambiguous case, those 2 triangles. All right, so we'll get to that and we'll practice some of that so you can see what's going on. But first, let's just rock the socks off of this and see what we've got. So here's example 1. I have triangle ABC. I'm going to solve this, given angle A, angle B, and side A. Now here's the deal. When I go to solve these triangles, just like we did before, I find it helpful to write out your angles and your corresponding sides. Then fill in everything you know. I know angle A, angle B, and side A. Fill in angle A, angle B, and side A. Then, this is also helpful because we've got a match. Anytime you have that matched up, that is your tip-off that you're using law of sines. Law of cosines happens if you don't have any matches, all right? Spoiler alert, that's how you know the difference between the two. Law of sines happens if you have a match, all right? Here, the best day ever, because we know triangles have 180 degrees. So if you know two angle measurements, you automatically know the third. So take your 180 from your triangle, subtract off the two you know, and then you have your one left over. All right. Then, to start solving for these sides that we don't know, that are sitting right there, then I'm going to take my known here. I'm solving for the side, so I'm putting the sides on top. So it has to be sides over angles. 42.9 goes with sine of 32. B up here, which I don't know, times the sine of 81.8. When you have two fractions that are equal, you can cross multiply. So I have B times the sine of 30, 42.9 times the sine of 81.8. That's just a basic, equivalent, ratios, cross multiply, do your business. Then I want to get that B by itself, so I'm going to divide by the sine of 32. Those cancel. And then I plug this into my calculator. If you are plugging this into your, practice that right now, plugging this into your calculator. If you're plugging this into your calculator and you are not getting this answer, then we need to troubleshoot how to use a calculator, like how to plug this in, not to be derogatory, but just how to plug this in and how to effectively use your calculator. Something I'm going to say, this is all in terms of degrees, so make sure your calculator's in degree mode. That makes an impact. All right, now you know B. Go back to the given. All right, go back to the given. That's always good practice to go back to what you're given, and we use that here. We're trying to find side C that goes with the 66.2. Again, you cross multiply, divide by that sine of 32, plug that into your calculator, and you get 74.1. Now notice, my problem doesn't tell me exactly where to go with that. Typically, we're using significant figures here. Because everything is 3 significant figures, my answer also needs to be in 3 significant figures. All right? Up here, that's this 2 digits and 1 decimal, 2 with 1 decimal, so then automatically your answers also follow that same pattern. Okay? Let's do some more. Oops. Did I skip a page? No. Okay. Here, I have this super awesome. I put this one in here so we could see the actual triangle of what it's talking about. A surveyor wishes to measure the distance across a river. See this figure. Thank you. She determines that angle C over here is 112.9. Angle A is 31.10. Side B is 347.6. Now, when I'm looking at this value, I have angle, side, and angle. I'm charged with finding the distance of A right here. So I know I'm going to have to use this ratio. Well, in order to use this ratio, I have to have a setup. Can I easily find B? Heck yes, you can. As soon as you know 2 angle measures, it's pretty much your best day ever. Because you can easily find that third angle. As soon as you find what this B is, whammo jabammo, you can now set this up with the law of sines. I need to find A, so I'm putting it in the numerator. And this is my setup for B. Cross multiply, divide by the sine of 36, and A is 305.5 feet. You don't have to have a right triangle to do trigonometry. All right? It just doesn't have to happen. Law of sines and cosines tells us we could do it with anything. All right? Okay, setting up this ratio, that is the key. Okay, so look at this one. Here, I have a fire. What? Here are two ranger stations on an east-west line 110 miles apart. A forest fire is located on a bearing of north 42 east. So here's my bearing of north, and I'm going to the east 42 degrees. All right? And from the western station A, and a bearing of north 15 east from station B. How far is the fire from the western station to the nearest mile? So I'm trying to find this B value. Okay, now you can see it here, but let's just work this out. I know 42 and I know 15, and that's it. What you also know is when I do a bearing, that makes a right angle. So I have these right angles, so I automatically know this is 90. So plus this additional 15 is going to be 105 for this full angle. All right, for my triangle. Over here, I know this top part is 42. If the whole thing is 90, this bottom has to be 48. And as soon as you know two angles, you automatically know the third, right? Because you can subtract it to get there. The reason why we need that third angle is because this is our matchup, right? That is our matchup. So as soon as I get this matchup, I can now get this matchup. And that's how we're doing our law of sines. All right, and here, it's obvious that we do the same thing each time, right? If I cross multiply, I know I'm multiplying this, I'll have to divide it. So you can go ahead, in my opinion, just divide that straight up. Just like up here, every single time we cross multiplied and you always had A or whatever it was times this value, then you ended up dividing it. Well, you know it's going to be B times this value. You're going to end up dividing this. So you can go ahead and just do that. And I know that it is 200, the fire is 234 miles away from Ranger Station A. All right. This is an actual legit problem. Like forest fires that happen, there are ranger stations out there all the time. That's Department of Forestry type stuff, right? And you want to say, how far away is this? How can I get a plane in there to dump something on that, right? Those fire jumpers. You want to get in there and you want to say, okay, how can I get this contained and taken care of? This is legit trigonometry, legit examples that actually happen, which is kind of fun to do, right? See something that legit goes down? Cool. Anytime you have two angles, you automatically can have that third angle and you can set up your law of sines. Law of sines is the way to go. Setting up those proportions is the best way. All right. So, what happens if I have this ambiguous case? Here are the criteria. If your sine is greater than 1, you're done. There is no triangle. There is no possible way I can have sine to be greater than 1 because we know that's a criteria. Sine can never be greater than 1. If I have sine equal to 1, then it is one triangle and it's a right triangle. All right? This is my angle, is a right triangle. If I'm between 0 and 1, I'm either going to have 1 or 2 triangles. I have to determine if my second angle can make that. And we'll talk about that. All right? For now, you either have no triangle. It could potentially be a right triangle. But if you have this scenario, whenever you have a side-side angle, right? Two sides, one angle, and you have a matchup, You have a matchup here, but it's two sides. This is the ambiguous case. Okay, so let's try this on. Here, I have the sine of A, because if I'm looking at my matchup, right, I have this match, so the next thing I need to find is the angle that goes with A. So, set it up. Cross multiply that. I've got the sine of A equals, if you multiply by that 8.94, you know you're dividing here. So 25.1, sine of 55 degrees, 40 minutes. Divide that out. Sine of A, is there any possible way it could be a 2.32? No. So the first thing that you're looking at here is, what is this value? And if it's something that is above 1, first criteria, then there is no triangle. There is no possible way for this side to be long enough, regardless of how I swing it, to hit all the way down here. That's not going to happen with that ratio, that given ratio. All right. Let's look at another one. Ooh. So this is exciting. Okay, so it sucks that all this is on here right now, but you know what, guys? We're just doing what we do. We're cool. We got this. So let's just talk through how I know this is happening. So step 1, I've got two sides here and one. So whenever I do this, I'm going to set this up over here. Automatic ABC, ABC, right? I know the stuff in blue, so put it down. Here I have a ratio. Ta-da! So I'm given this side. So this is the first angle that we're going to find, because I can set up that trig. Cross multiply here. I've got my sine is 89.786. So we're within our range, right? So we know, okay, I can actually get an angle measurement out of this. Do your inverse trig in your calculator. So inverse sine of this business. And you get 63.9 because you're using that same significant figures. And I get 63.9. Now here is where you have to check. When you get this first angle, right? I haven't done anything with C yet. I know it's up here, but pretend like it's not. I haven't done anything with C yet. So because of that, as soon as you get this first angle measure, you immediately come over here and you say, do I have a second? Do I have a second triangle? I'm going to take 180 minus that angle measurement to get 116. All right? Then I'm saying, okay, I'm already given this 55.3. I have that. I have the potential of a 116. So of my 180 degrees in my triangle, take out what you already know, take out the possible B, and see if you have anything left over. If you have something left over, you have a second triangle. And that's how you figure it out. You say, so if I come back to this criteria, 180 minus the angle that I already have. All right? Minus that angle that I already have. If you go with my new one plus what you already have, it has to be less than 180 to get that second triangle. If I have these two here, I have to be able to have something left over for that third angle. All right? And lo and behold, we do. And that's how you know you have a second triangle. You just have to check it. Find this one first. Get its complement, right? Or, not complement, for crying out loud. It's supplement. For Lordy Bagordy, get its supplement out of this deal. And then you see if you have anything left over from what is given. This comes from my given. If A is given, then that is also given here because A is stationary. It just is what it is. I'm going to show you a picture here in a minute of what that looks like. But let's work this out first. If I have a second triangle, if I'm given information for the first one, the exact same information is given for the second triangle, and we'll show you what that is. You now have these angle measures. I can come up with my third angle up here. And now I have all my angles. The only question now is, what is side C for each one of these? So side C, if I come over here, use the given ratio, right? Use the given ratio with your side C. Do that work and you get 24.2, right? Cross multiply. 22.8 divided by this sign. Plug that in your calculator. It's always good to pause the video and check it on your calculator and then start it back up again. You get that? Cool. Then you come over here, the same thing. Go with what you know. Solve for C over the sine of 8.6, a tiny little fella, isn't it? And then you get 4.09. Look at what's happening here. Here I have all of these significant figures, so you need to get it at 4.09. Here this is all rounded to the 10th, so we're good. And you actually get two triangles out of this. Here is what they look like. You've got this tiny little triangle right here. That is actually this one. So your side of 22.8, all right? You can have a side of 22.8 that has these angle measurements that you're talking about. You can also have a side of 22.8 that comes down in here and makes a nice big angle. Whether I have this angle here or this angle, those are going to be supplements of each other. All right? Okay. And that's what it looks like. This setup right here is this how that triangle happens, because it's both at a 55.3, and my angle, or pardon me, my side over here is 24.9. So when you have that angle side situation, I've got an angle, a side, could be a side here, angle a side, or could be a side coming down this way. And that's how you get your two different triangles. And then go back to what we've already talked about and what we already know. Look at what's happening here. This angle is super small, so look how much smaller this is than our other sides and how they match up. All right? Okay. So here is a situation where I have that ambiguous case and I have those two triangles. I had my ambiguous case over here and I had 0 triangles. I could just have one triangle, right? Let's try it on. Again, I'm given this information, so I've got my matchup of A's, and the C is what's given in this particular problem. So because I'm given side C, I have to find angle C, and it don't matter which one you do. But, I mean, in terms of whether you're given B or C is what it doesn't matter. Whatever you're given, it definitely matters that you have to find that angle first, right? There's no way to get anything from B otherwise. So do the thing. Set it up with your proportion. You've got this. Cross multiply. And I get 0.46 here. With this 0.46, that's between 0 and 1. So I know I can do my inverse trig. And I get side C, pardon me, angle C is 27.6. When you have the ambiguous case, two sides, one angle, you have to check to see if you get that second triangle. So I've got 180 minus this to see what the supplement is. I'm given angle A, right? So angle A is 43.5. My potential second here is 152.4. Do I have anything left over here for that third angle? No, indeed. There's no possible way. So this one, if I'm looking at this, I do not have a second triangle. And the only way you're going to know is to find the supplement and see if your given angle will work with it. That's the only way to figure it out. If it doesn't, then you're out. So, okay, then I have a lot less work I have to do. As soon as you know 2 angles, it's easy to find the third. Get that third angle. Use that with your given ratio. Use that given ratio, and I'm trying to find a side here. Cross multiply. Divide by that sine of 43.5 because it's with my b. And then I get 14.7. So that ambiguous case is a deal, right? You're either going to have 2. So if you have a matchup, that's the key. I've got a matchup, but I've got 2 sides here. You always have to check for that second triangle. And if you have one, then you do that extra work that goes with it. If you don't, like in this case, the supplement doesn't work, then you're finished and you just have the 1. All right, practice those and then let me know if you have any questions.